Hello guys, today we're doing LeetCode question 994, rotting oranges. The question is, you are given an m by n grid where each cell can have one of three values. 0 represents an empty cell, 1 represents a fresh orange, and 2 represents a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. So 4 directly adjacent means above, below, right or left of the current cell. So return the minimum number of minutes that must elapse until no cell has a fresh orange. If it is impossible, return -1. So, example 1, the input grid is 2, 1, 1, 1, 1, 0, 0, 1, 1. The output is 4. As you can see here, there's a rotten orange there. So we check the ones adjacent. So below and right become a rotten orange. Check the ones adjacent for that. So below and right of this one become a rotten orange. So that's now 2 minutes. Now we'll check the ones below and right of this one, and left and bottom as well. So that one becomes rotten. This one, there's none around it, aren't rotten, so that is 3. For this one, we then go to the right, that becomes rotten, so that's 4. That's why it's 4 minutes. Example 2, grid 2, 1, 1, 0, 1, 1, 1, 0, 1. Output is -1. The orange in the bottom left corner, row 2, column 0 is never rotten because rotting only happens 4 directionally. Okay, so the way we're going to do this is with breadth first search. So we pretty much just check each direction, and then for each child that's been rotted, we then do the same, check all the directions around it, and then we increment a count each time we go through a level, if that makes sense. And that count we then return as the count -1, because even when the last one is returned, we'll push that into the queue, and that will check all the surrounding values and add a count. However, as there's no surrounding values, as it's the last rotten orange, it will add a count, so we need to decrement it by 1. Let me show you how it's done in code. Okay, so we have our matrix here. Save matrix, or our grid. This is our grid. Now the first thing we do is we initiate a queue to store our values that we're going to infect. So let's just say queue here. What values that we're going to rot? So the orange we're going to rot, or that are rotten. Sorry. For now it's empty. Then we store a value of fresh here, which is 0. This represents the amount of fresh oranges that are in the grid that we have to rot. We then compare it to the end count, and if they match, or if fresh is 0, that we've removed all the fresh values, we then return the count, because we know all the fresh values have been rotted. And then we store directions. So it counts each position from the current cell, which will be above, which is, so let's do right, which is 0, 1, left, which is 0, -1, above, which is -1, 0, and below, which is 1, 0. So that's a direction array. Now the first thing we do, we also increment our count to represent how many oranges are current, how many minutes it taken to current oranges. Count is now 0. So the first thing we do is loop through the grid, and for each fresh value, we increment the fresh value, and for each rotten orange, we add it to the queue. So 2 represents rotten orange, 1 represents fresh. So let's start from here. 2 is rotten, so we then push that value, the position, to queue. So that is now 0, 0, 0, 0. Then we go to the next value. 1 is fresh, so we increment fresh, and so forth. So fresh at the end will be 5. Let's remove these. That'll be 2 and 1, 2 and 1. Okay. Now that we have our queue, we're going to loop through. We're going to do a while loop. That while queue is not empty, we're going to rot the ones around it, and we save a length. So let's say queue is now 1. So we iterate through. We save our length of queue, which is 1, which means we have 1 level to go through. So we know this one is rotten. Let's rot the 0, 0. Then we check the ones around it. So we know the top one is out of bounds, left one is out of bounds, so we leave those. We then check right value. We know right value is fresh orange, so then we rot that as well, and we push that to the queue. So now in the queue, we also have 0, 1, 0, 1, 0, 1. Okay. This is the current coordinates we're rotting around. And then we decrement fresh. As we know, we've rotted one orange, so fresh is now 4. Then we check the bottom value of the position. That's a fresh orange. We wrote that as well. So now we push that to the queue. Now queue also has 1 0, 1 0, and then we decrement fresh. So fresh is 3. Now we remove length. We've done that. Length is now 0. So, well, length is not 0. Length is 2. But we remove the position here. Now we have 2 values in the queue. So length is now 2. So now we go to the next one, 0 and 1. So we're here. Now an account is incremented as well, because we signify that we've done 1 round of rotting, or 1 minute. Now we wrote the current values around 0 and 1. So we check the top value is out of bounds. Our left one is not rotted, we leave it. So check our right value. Now our right value is fresh, so we wrote that as well. Push it to the queue. Now queue also has, let's make these better. 0 1 is going to be removed, so it'll be 0 1 1 0, and now it has 0 2. So then we signify we've removed the fresh orange. We've done that, so fresh is now, okay, it was meant to be 6 at the beginning, but anyway, we say we've already removed it. Then we rot it, we remove the value from the queue. Next we rot the bottom value of the position, current position. Here we add that to the queue, which is now 1 and 1. So 1 1 here in the queue. 1 1. And we've done both values. So length is finished, and we increment count. Count is now 2. Then we check our values surrounding the next position, which is 1 0. So here we check left, it's already been done, top's already been done, so we check right. Right is not orange, so we leave it. We check bottom. Okay, bottom is a fresh orange, so we wrote that. We push that to the queue. So now 2 1 is also in the queue. 2 1. And we remove a fresh orange here. So now there's 2 fresh oranges left. And we remove that value from the queue. So now we're at 0 2 here. We check the left side, left's already been done. Right is out of bounds, left is out of bounds, and bottom is not a fresh orange, so we leave it. Now that we've done both values, we increment our count to 3. We delete that value. So now Q is 1 1 and 2 1. Sorry, 1 1 has also been done. So I removed that. So now Q is left with 2 1, which is our last rotten value. So Q is with 1. I've got to decrement the fresh value as well from before, so that's 1. And now we are here, 2 1. So we check left is not orange, top is already done, right is a fresh orange. So we wrote that as well. We push that to the Q. So now Q has also got, let's move 2 1 because we got that, 2 2, 2 2. Okay. Now we remove the last fresh orange, fresh is 0. We've done that value. Now count is incremented, it's 4. Now we'll check 2 2. Is left a fresh orange? No, that's already done. Top is not orange. Right is our bounce, bottom is our bounce. So we end our while loop. Now we check if fresh is equal to 0, then we know we rotted with oranges. So we return count minus 1. Reason being, as I mentioned before, the last value still increments the count, although there's no more oranges to rot. So we have to decrement it. And if fresh is not 0, we know we've not rotated with oranges, so therefore we return -1 because we cannot roll with oranges. Let me show you how it's done in code. So first thing we do is we create our queue. Then we create our fresh count. Fresh 0 and let count to 0, which counts our current minutes. Then we create our directions. So const directions is equal to an array of position 0, 1, which is right, 0, -1, which is left, 0, 1, sorry, 1, 0, which is bottom, and -1, 0, which is the top position. Now we loop through our current grid. So for let row is equal to 0, then the row is smaller than grid.length, row plus plus. We go for our columns. So for let column is equal to 0, column is smaller than grid, row.length, row plus column plus plus. Okay, now we check if our position, so if grid, so if position is a 1, we know it's fresh. It's 1, so we increment fresh, fresh plus plus. Else, if position is 2, so grid row, we know it's rotten, so we push it to our queue. So queue dot push grid, no, sorry, it's the position. So roll call. Okay. Now we have to do the breadth-first search. So we loop through the queue while it's not empty. So while queue dot length is bigger than 0, and we loop through the queue. Then we save our length of the queue. So let length is equal to queue dot length. Then we loop through each value. So what for? We're gonna do while length bigger than 0, and we continue. Then we loop through each direction. So for let row column of directions, then we iterate. Okay, then we got our node. So let node, actually get our node first here. So let node is equal to queue.shift, which is our first value to loop through. Then we loop through the columns. So let new column is equal, or we get our column source. So let's do let current col, current row and current col, which get the current position of the nodes that we're looking through. We get new col is equal to current col plus, let's do row first, just to get it in order. So new row is equal to current row plus row, new col is equal to current col plus col. Okay, then we just have to check that they are in bounds. So if new row is bigger than or equal to 0 and new col is bigger than or equal to 0 and 0 and new row is smaller than grid length and new col is smaller than grid row length, we know it's in bounds. But then also the position has to be a 1. So and grid row col is equal to 1. Now we know that we're in position and we have an orange to roll. So what we do is we set the value in the grid. So grid row col is now 2 because we've rotated it. Then we push the value into the queue. So queue.push, grid new row new col, and then we push the new position new row new col, and then we signify we've done we've rotated one orange, so we decrement fresh, and then we decrement length to signify we've done one length. And then while we've looped through that whole row or the whole surrounding elements, we signify we've done one count, So 1 minute, we increment the count. Then we return true if fresh is equal to 0. We return count -1, else we return -1. Now let's see if that passes. Oh no, wait, I think we missed. We have to check if new, okay, if new grid row length row is not defined. Okay, yeah, grid, sorry. Grid new row. Let's see. We've missed one statement here, which outputs 0, which I'm going to show you now in a second. Let me fix this grid. New row, new call. Yeah. They should pass some tests, but we need to change this statement here. Yeah, oh, okay, pass the move. Oh yeah, because count will remain 0 anyway. So let's submit. Answer expected. Okay, yeah, this is what I was meant. So here we check if there is no fresh values, then we know there's nothing to rot, so we return 0 because they're already all rotten. So if fresh is equal to 0, then we just return 0. So that should pass all tests. There you go. Now the time complexity of this is OM of n. As worst case, we loop through the whole grid, and our space complexity is also OM of n, because worst case in our queue all elements are rotting or rotted, so we have to store the whole grid in the queue. Thanks for watching.